Okay, Bismillah ar-Rahman ar-Rahim. Welcome everyone. This is a tutorial session for problem set 5 for check 205. So let's start with the first question. We are asked to estimate the molar volume and the density of a gas mixture at a temperature of 60 degrees Celsius and a gauge pressure of 3 atm. And we are given the composition of the mixture. Keep in mind that we are asked to find the molar volume in a certain unit, which is meters cubed per mole, and the densities in kilogram per meter cubed. So let's start solving. We have from the equation of the ideal gas law this relation. And keep in mind that the pressure needs to be the absolute pressure and the temperature needs to be the absolute temperature in Kelvin. So from the definition, the absolute pressure is equal to P gauge, the gauge pressure plus the atmospheric pressure. So we have 3 atm plus 1 is equal to 4 atm. And the temperature, we will add 273.15 to convert it into Kelvin. And now we can find the molar volume. There is one thing though, we have to pay attention to the unit of R. So first I will just, okay. Now you can use this value of R. Here I have put for you the values of R. You can use this value, but we will need to convert the liter to meters cubed, or you can use this value of R but convert your pressure to Pascal so that your equation is homogeneous. So I decided to use this value of R, 0.08206. It will be in liters times atm per mole Kelvin. And I will need to convert the liter to meters cubed. So 1 meter cubed is 1000 liters. Then I will multiply by the temperature. This is a 5. Then divide by the absolute pressure, which is 4. If you do this calculation, you will get the molar volume to be 6.83 times 10 to the power of negative 3 meters cubed per mole. Okay, so let's move to the other part of this problem. We need to find the density in kilograms per meter cube, and we will use this relation. The density is equal to the absolute pressure times the average molecular weight over RT. Now we have P, absolute, we have R, we have T, we need to find the average molecular weight. We will use the compositions, and as we learned, that the average molecular weight is equal to the summation of the molar fractions times of each component times the molecular weight of each component. The sum of the molar fractions times the molecular weights of each component. So here you have the composition of O2 is 15%, which is 0.15, times the molecular weight of oxygen, which is 32, plus the molar composition of nitrogen, times the molecular weight of nitrogen plus the molar composition of CO times its molecular weight. And then we will have left the molar fraction of CO2 and the molecular weight of CO2. Now the average molecular weight, if you do this calculation, you will get it as 29.72 gram per mole of the mixture. Okay, so we just substitute this into the formula. Again, keep in mind that this is the absolute pressure. So 4 atm times 29.72 over the gas constant. And again, I will keep my gas constant in meter cubed. I forgot to add my units above, so I will add them again. It's good so you're keeping track of the units to avoid some mistakes. And this will be multiplied by the temperature. Kelvin. If you do this calculation, you will get the answer in grams per mole, and grams per meter cube. And you will need to convert the grams into kilograms, an easy conversion. So the final density will be 4.348 kilograms per meter cubed. So these are our final answers, boxed in purple.